Today we're going to talk about solving systems of equations. A system of equations, first of all, is two or more equations with two or more variables that rely on each other. We solve these systems by graphing, substitution, and elimination. There's three different types of systems of equations. There's consistent independent. That means the system only has one solution. That means when you graph the solution, the two or more lines cross at one point. And algebraically, when you're done solving, you get a variable equal to a number. So like x equals 2, and then you solve and get y equals -3. That would be a one solution equation. If the system is consistent dependent, that means the system has infinitely many solutions. Graphically, that means two or more lines are the same, only they're written a little differently. Algebraically, that means that when you're done solving the system, you'll get a true statement like 0 equals 0, 2 equals 2. It's very similar to the conditional linear equation from earlier in chapter 3. If you have an inconsistent system of equations, that means there's no solution. Graphically, that means two or more lines never cross, so that means that they're parallel. Algebraically, when you're done solving, you get a contradiction, so 0 equals 2 or -4 equals 7. Those are all contradictions. Let's solve these equations, or graph this system to solve it. We want to put the first equation in y-intercept form because it looks like it's pretty easy to get there. So let's add 2x to both sides. And we have y equals 2x plus 6. So we graph our y-intercept of 6, and our slope is 2, so that's up 1 over 2. Down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1 again. And we'll connect our line carefully, because when you're drawing on a graph, sometimes it's kind of hard to determine where the numbers cross, or where the lines cross. So now we're going to graph y equals -1/4 x minus 3. So we have -1/4, or -3 is our y-intercept. Our slope is -1/4, so we're going to go down 1 over 4, or up 1 over 4, and sure enough, that's where the lines cross. So we'll carefully draw our line. And then our solution is where the two lines cross. So our solution is going to be at -4, -2. We plug these points back in. You can plug them into both to determine if your answer is correct. When you graph, you really should do that. So we'll do that quick. -2 times -4 minus 2. So that's 8 minus 2, which is 6. So that one checked out. And we have -2 equals -1/4 times -4 minus 3. So that's 1 minus 3, which is -2. So that one checks out too. So our solution is -4, -2. We can do the same thing with inequalities like we did earlier. So we're going to graph the lines. We'll add 2x, and we have y is bigger than 2x plus 6. Graphing those lines, we have 2x up 2 over 1, down 2 left 1. So there's that line. Picking our point 0, 0 as our test point. We put 0 in for x and y. We have 0 is bigger than 6. That's false. So we're going to shade away from 0, 0. So here's 0, 0. We're going to shade on the other side of the line. So now let's do the other one. I'll use green again. And we're going to graph the y-intercept of -3 and the slope of -1/4. So there's our line. And then we want to use 0, 0 again to test. So we have 0 is less than or equal to -3. That again is false. So we're going to shade away. So we would shade this side of the line. So our solution is actually this area right here, because that's where the two shadings cross. Alright, now we're going to solve by substitution. Substitution means we're going to take and substitute one of the variables out. The second equation says y equals this right here. So we're going to put this in for y up here. So we're going to have -2x plus -1/4 x minus 3 equals 6. So this was where the y was to begin with. We don't like fractions, so we're going to multiply everything by 4 to get rid of the fraction. So we have -8x because we're distributing. -2 times +4 is -8x minus -1/4 times 4 is -1x. -3 times -4 is -12 equals 6 times 4 is 24. So now over here we have -9x minus 12 equals 24. -9x, we're going to add 12 to both sides. -9x equals 36. So, and then divide by -9. So x equals -4. Now we want to plug this back in to find y. Since y is already isolated over here, we'll use this one. So y equals -1/4 times -4 minus 3. So y equals +1 minus 3. So y equals -2. Our solution then is a pair of numbers, an ordered pair, -4, -2. This is actually the same solution we came up with here, and this is how we've already checked it. Since if you were solving just by substitution, since this equation is the one we use to find y, this would be your check equation. You never want to use an equation that you already used to solve, because otherwise you may be compounding the same mistake. If you don't know which one to use to check in both. It takes less than a minute. Alright, so then we have elimination. Elimination means we're going to eliminate one of the variables. So there's a couple things to look at. First, you want to eliminate either the x's or the y's. And to do that, first you would look and see if one was if something was different signs. So if one was positive, one was negative. We don't have either of that for either of these cases. If one was a multiple of one and the other, so if this was 6 and that was 12, then we would go after the x's right away. But right now, we don't really have that either. So, instead, I typically, when something like that happens, I just go after the x's, just as a matter of habit. You don't have to. You can use the y's if you want to. And we're going to multiply this first equation by the coefficient of the second equation. So we're going to multiply the first equation by 7, and the second equation by 6, And then we need them to be different signs, so one of them is going to be negative. Again, it doesn't matter which one. So then we're actually going to do all the multiplication. So we have 42x minus 49y equals, I'm going to pull up my calculator quick. I can't do 13 times 7 in my head right now. That would be negative 91. The second equation we'll write right underneath. We have negative 42x plus 18y equals positive 60. Negative 6 times negative 10 is positive 60. Now see, when we can add our two equations together. That's why elimination is sometimes called the addition method. 42x minus 42x is 0. Negative 49y plus 18y is negative 31y equals negative 91 plus 60 is again negative 31. So then we divide both sides by negative 31 and we get y equals 1. That's 31, not 3y. To find x, then we have to use one of the two equations. So we'll go back to the first equation, and we have 6x minus 7 times 1 equals 13, and we're going to solve for x. So 6x minus 7 equals 13. So 6x, we're going to add 7 to both sides. 6x equals 20, so x equals 20 over 6 when we divide by 6 on both sides. That means it would be 10 thirds. Solving, does that make sense? Let's check our answer with the other one. It doesn't make sense. Let's see. So sometimes people make mistakes. So let's see where we made this mistake. 42 minus 49 minus 91. 42 negative times negative is positive 18. Positive 60, so that's positive 1. This was negative 13. It's always those pesky negatives. So when we add 7, so when we add negative 13 plus 7, we get negative 6. So x equals negative 1 when we divide both sides by 6. The reason I knew it wasn't going to work out was because there was no way to have the fraction work in the other equation. But notice how the first thing I did when I was checking my answer, because I knew it was wrong, was to check and make sure about my negatives. Somehow that's always seems to be the one that people make mistakes on. Not always, but a lot of times. So then let's check our answer. We use the 6x equation to start. So we're going to use the 7x equation to check. So we do 7 times negative 1 minus 3 times 1. That's negative 7 minus 3, which is negative 10. So it checks out. The last one we're going to do today has a whole bunch of fractions. So the first thing we're going to do is get rid of the fractions. So the first equation, we're going to multiply by the least common denominator, so we're going to multiply by 10. The second equation, we're going to multiply by the different least common denominator, so we're going to multiply by 4. So when we multiply the first equation by 10, we have 10 times 1/2 x, which would be 5x, plus 10 times 2/5 would be 4y equals 20. 4 times 1/4 x would be x. And 4 times 1/2 y would be minus 2y equals negative 24. Now see the x, we have 5x here and x here. Here we also have 4 and negative 2. This is plus and this one's minus. So I'm actually just going to multiply this second equation by 2. Because we have a plus and a minus and it's a multiple. That way when I'm all done I don't have to change any signs. As you can see from the previous example, that's probably a good thing with negatives sometimes. So we're going to rewrite our first equation as is, and we're going to multiply our second equation by 2. So that becomes 2x minus 4y equals negative 48. Add our two equations. 5x plus 2x is 7x. 4y minus 4y is 0 equals 20 minus 48 is negative 28. Divide both sides by 7. And we have x equals negative 4. Using one of those two equations to find y, let's put it in the first equation. So we have 1/2 times negative 4 plus 2/5 y equals 2. Notice I'm still using the equation with the fractions. I'm not going back here in case I made a mistake. That means we have negative 2 plus 2/5 y equals 2. Add 2 to both sides. We have 2/5 y equals 4. We're going to multiply everything by the reciprocal, which is the same as dividing. So 2/5 times 5/2, those divide out, and we have 4 times 5/2, so that would be y equals 10. Let's do a quick check. We use this equation to find y, so we'll use our second equation to check. So we have 1/4 times negative 4 minus 1/2 times 10. That's equal to negative 1 minus 5, which is negative 6. So that checked out. So our solution then is negative 4, positive 10. That's it for today.